Hello, everyone. I'm happy to welcome Jeff Ivan from Soilgenic, and he's going to be speaking about the next generation enhanced efficiency fertilizer technology. So take it away, Jeff.
Thank you. Good morning and good afternoon. Soilgenic Technologies, we're focused on enhanced efficiency fertilizers. And first off, I want to start with synthetic fertilizers feed people. And I think the industry, this is one of the biggest developments that we've had since the early 1900s when the Haber-Bosch process was developed. And if you look at synthetic nitrogen, it supports the population growth that we saw from 1.6 billion to 7.6 billion today. And it was a major challenge at the time to create synthetic ammonia. And if you look at the next challenge, which is how will we feed 10 billion people by 2050, this is the real question that a lot of people ask. So Soilgenic is, we like to say, innovating tomorrow's future today. Our vision is to reduce greenhouse gas emissions and environmental impact by implementing climate smart technologies. And we're focused on helping the world grow sustainably. So what does that mean? Climate smart technologies. Essentially, it's two areas that we're focused on right now. One that we'll be talking about today is enhanced efficiency fertilizer technologies that improve fertilizer efficiency and reduce loss to the environment. The second technology is green ammonia. And the green ammonia is essentially improving the efficiency of ammonia production. As mentioned, the nitrogen production or the creation of ammonia from the early 1900s is a brown process, as they call it, which emits carbon, and roughly each year 500 million tons of carbon is emitted to the environment. So it's one of the most carbon intensive chemical processes, and there's a big challenge to reduce the amount of green ammonia emissions to the environment. We've partnered with the scientist who developed the leading carbon capture technology and the platform that allows him to capture carbon at a very low cost. This technology is now being used for RNG gas separation technology, as well as the production of hydrogen, and will also be used for green ammonia production. So if we look at our challenge, the global food chain needs to produce, as mentioned, 50 to 70% more food to be and be sustainable at the same time. As we know, consumers are demanding wholesome foods while being sustainable. But the real challenge is the global population increase and food security around the world. The challenge that we're facing today is that the climate is changing. And as we can see what's happening right now out in British Columbia and Canada here, we had horrific forest fires this year out west, not just in Canada, but in the United States. We're seeing flooding, which is occurring on a regular basis in a lot of places around the world. And that is putting a big emphasis on how do we make agricultural production more sustainable. So if you look at nutrients in general, nitrogen, phosphate, while they're very beneficial, as we know, nutrients are being lost to the environment, and it contributes to climate change and environmental issues. Climate change from nitrous oxide, from nitrogen, is 300 times more potent than CO2. Aquatic dead zones from the loss of nitrogen and phosphate fertilizer runoff contributes to red tides, and of course the depletion of oxygen and fish kills. I spent some time with the Sulfur Institute out of Washington, D.C. I was project lead for developing sulfur use in the market in India. India was one of the most sulfur deficient markets, soils, because they overused nitrogen, and they had a lot of problems with nitrogen leaching into the groundwater, creating high nitrate levels and problems such as blue baby syndrome. So at the end of it is fertilizers need to be more efficient. And if you look at nitrogen, we lose up to 40% globally. We're very efficient here in North America in terms of how we manage nitrogen by banding it into the soil, but we still lose nitrogen, and we need to look at how to make it more efficient. Phosphate efficiency is roughly 90% is unused in the year of application. So that means we need to build up a bank of phosphate. And the real question is, how do we make phosphate more efficient? And if you look at enhanced efficiency fertilizers, it's a term basically that is used for formulations that control fertilizer release or alter reactions that reduce nutrient losses to the environment. So our vision in reducing nitrogen loss to the environment must include, we believe, green ammonia and enhanced efficiency fertilizers. And changes coming. The United Nations Environment Program called for countries to have nitrogen waste by 2030. And that was the Colombo Declaration in 2019. Just to give you an idea, at that time, they said this is roughly $100 billion of nitrogen that's being lost. If you were to have nitrogen waste. And our vision, as mentioned, is that you must look at how do you control greenhouse gas emissions, reduce the waste there, but as well as enhanced efficiency fertilizers that can reduce loss in terms of above and below ground nitrogen loss. If you look at the Canadian economy, we have a new climate action plan that came out, and the climate action plan calls for a 30% reduction in emissions from 2020 levels. This is a major challenge for Western Canadian or Canadian farmers in general, because there's a real drive to just reduce fertilizer in general. And as we heard from other presenters, this is a bad strategy. So the government is looking to improve synthetic fertilizers, create better products and technologies, and that's where we come in. The other issue is high nitrogen prices, which is really caused by high natural gas prices. As natural gas price increases, we see higher costs of nitrogen, and this is a problem. How do we increase the fertilizer use efficiency to get more of that nitrogen into the plant? So our solution is enhanced efficiency fertilizers. We have a family of over 50 patents in this space. I'll be talking specifically about two major patents that we have, and they will make a tremendous impact on the market. When you look at enhanced efficiency technologies, you have downstream technologies where most of the application occurs. This is at the fertilizer retail level. Basically, the fertilizer retailer will coat the nitrogen with an enhanced efficiency product. But what's happening now is there's a couple of things. First off, not every system is the same, so getting the coverage is a challenge. But secondly, there's more products now being coated. We're seeing phosphate efficiency products that are being coated at the same time, as well as micronutrients and biologicals. So this is getting to be a very crowded space at the downstream level. So the real question comes, how do we make it more efficient? So the area that we're focusing on, as well as downstream, is to move upstream and create a manufactured fertilizer where we can add enhanced efficiency into the granulated fertilizer. This will increase the efficiency, increase the quality, and lower the cost of production. Some of our research, just to give you an idea, will show that we can increase urea hardness by 20% with our enhanced efficiency technology that's added at the granulation stage. So the science of nitrogen loss, again, I mentioned above ground loss, that's called volatilization. The urease enzyme basically converts the urea into ammonia gas. Urease inhibitors such as NBPT has been used for 20 years in the market, so it's not a new technology, and it's been very effective. Below ground loss protection, or leaching, or denitrification, is again bacteria, the nitrosomonas, the nitrobacter bacteria, that is essentially converting the stable ammonium nitrogen to nitrite and then nitrate, which is now susceptible to loss in the soil. And again, technologies such as DCD, dicinamide is used to coat the fertilizer and basically slow the bacteria down, make them go to sleep, so to speak. And basically the result is you get a gradual release of the nitrogen and a reduction of nitrate nitrogen, which can be lost to the environment. This is a great slide here because I think it shows the effects of above and below ground loss and also total protection. What you see on the left is corn cob with no protection at all. You can see the filling up to a certain point. And then the next corn cob to the right shows above ground loss protection. And then the next one to the right shows below ground protection. And then of course, the last one is total protection, both above and below ground. And if you look at the yields from 176 all the way up to 219 bushels, you can see the dramatic increase in crop quality. And that's all about just preserving that nitrogen, keeping it from being lost to the environment and moving it into the plant. So one of our main disruptive technologies that we're bringing forward is a low-cost and improved NBPT production process. We're able to take this technology that is typically produced in China. There's 2 plants right now in China. Supply, as you know, with everything is very limited these days, but because of the requirement that we're seeing around the world and the demand for NBPT, this is a new in situ manufacturing technology that we feel will have a tremendous impact on the market. First off, it significantly lowers the raw material production cost by about 50%, and it reduces energy consumption, eliminating the need for drying and crystallization. Better, more environmentally friendly product. And most importantly, we can produce it locally. So if the product is needed for North America, you can produce it in North America. If you need it for Europe, you can produce it in Europe. So that is one of the major downfalls of the downstream retail distribution, is because you're moving product inefficiently throughout the network, where this can be done more efficiently up at the manufacturing level or locally in the market and then distributed downstream. The second patent is the granulation technology, where we're adding enhanced efficiency into the urea granulation. So Enzys is our upstream granulation nitrogen conservation input system. And we call it the efficiency train, where we're adding multiple efficiencies into the granule. First off, we can do nitrogen efficiency technologies. We can add in phosphate enhancement technology, and we can even add in micronutrient technologies. And that's the key to an efficient distribution of micronutrients. And our belief is that having a micronutrient distributed throughout each granule is much more efficient that way. Opti-N, or Optimum Nitrogen, is our completely protected nitrogen technology, and that includes above ground and below ground protection. And again, with this technology, the manufacturer can choose whether he wants above or below ground, or both technologies built into the granule. The other part of our technology is we patented a molecule, Nitrifidine. It's an enhanced DCD molecule. Long story short, it basically makes the molecule longer with a higher molecular weight. And those blue circles are triple nitrile bonds. Those are the cyano group, or the bonds that really do the work in the soil, and they will break down in the presence of water and slowly basically slow down the breakdown of DCD, meaning you have a slow release below ground product, which is going to last longer for you. So downstream technologies, we have the neon technologies, which is high analysis for urea and UAN. We have Diamond N for UAN protection. This is, again, a formulation that's fully soluble. You don't have to worry about it separating out in your UAN. It's going to work very effectively at a reduced cost. N-bound is for ammonium sulfate and ammonium-based fertilizers such as MAP and DAP. Drive-in is a non-corrosive formulation for anhydrous ammonia. And if you look at the technologies on the market today, they're difficult to work with, they're corrosive. This is a product that we feel will have a big impact because of the non-corrosive nature of the product. For phosphate, we have a phosphate enhancement product. 2 years of studies have shown a 17% increase, 7 to 10% return on investment. You can either apply to phosphate or to urea if you're doing an application mid-season to increase phosphate uptake. And this is some of the research that we've done showing the increase overall, a 20% yield increase with the product. What's in our pipeline? We've got new urease inhibitor molecules. We've patented one. It's in the process. It's better, less expensive technologies. We're looking 10, 15, 20 years down the road and where we're headed. A non-plastic biopolymer coating technology, in situ micronutrients, better performance, lower cost, and technologies for animal feed as well. So these are some of the technologies that we're working on today. Thank you.
All right. If anyone has any questions, you can just put them in the box there. Thanks, Ivan. Or sorry, Jeff. Now, I had a question. You and I chatted a little bit before this because some of the technology, and we talked about broadcast spreading and hand spreading. So can you just elaborate a bit on that?
Yeah. In my last role, I've spent 15 plus years working international markets, and I worked with NGOs and governments in Africa. And if you look at fertilizer loss, when I talk about 40-50% loss, that's the average loss that we're seeing globally. And in some markets where you're seeing a lot of broadcast applications, high rainfall areas, that's where you're getting a tremendous amount of loss. So again, to stabilize that nitrogen is important, and for that nitrogen to come from the manufacturer already stabilized, I think that's the key. If you're putting the nitrogen in the soil, you will get some level of efficiency built into that because it's now encapsulated in the soil, but you're still going to have below ground, denitrification and leaching from the nitrogen as well, but it won't be as severe as a surface application that you would have in a climate that is very hot, humid, and with high rainfall events. So,
okay, I have a question here. It's from Jordy. He says, I'm a student at Lakeland College in a Bachelor of Agriculture Technology. How long have you been working on this technology?
Well, the company itself, the Soilgenic, first off, Soilgenic is an incubator of technologies. We're looking at bringing in technologies that are sustainable, whether it be established technologies or whether it be new innovative technologies. This particular group has developed what we call Generation 1 technologies. They've been out for probably the better part of 8 years, I would say 7-8 years. And so there is some distribution going on in the market, but the new patents that are just coming out now, those are the new exciting technologies, the NBPT production technology, the granulation technology. That's all going to impact the market and allow producers to be creating fertilizers that are more efficient. So they're well researched. We've done the research trials, the granulation trials, and we know the active ingredients very well. And they're exceptional, and they'll work extremely well in the market.
Okay. I don't see any more questions. If anybody has any questions, you can just put them there in the box. I think you mentioned for storage of this type of chemical. So I'm assuming the granulation is a lot easier than others.
Yeah, no, I think that's a good point. One of the problems, and I touched on it a little bit, was for mass adoption. If you're looking at treating your urea all at the retail level, it's going to be increasingly difficult because of the sheer amount of technologies that are coming forward, where you're coating your nitrogen, you're coating your phosphate, you're coating the entire blend with micronutrients, maybe a biological. So at that stage, and you're also doing it in a very busy season. So um, for fertilizer manufacturers to implement it and have it shipped out fully protected, it's like building a car and not shipping a car with seatbelts, right? We know seatbelts work. We should be using seatbelts, and it's the same with
Mhm.
enhanced efficiency technologies. And if you look at where the government is going with the reduce 30% rate of fertilizer, what they really want is reduce losses of nitrogen to the environment. And that's where we come in. We can build that technology into nitrogen. We can build that technology into phosphate and create a more efficient fertilizer, so that if you broadcast it, if you put it in the soil, you're going to have the confidence that it's not going to be lost to the environment.
Okay. And that loss that you're talking about, when you said, if you mentioned 40%, now over a period of, sorry, it takes longer over a period of time. So does that percentage still stay there, or is it just takes longer?
Yeah, it basically is. It varies by soil type. It'll vary by climatic conditions. Um, some active ingredients will last longer than others. That's why if you look at nitrifidine, the molecule called nitroblock, that's our technology. That's important because that gives us a longer lasting DCD, because it's a longer molecule in the soil. So again, ideally creating a longer lasting throughout the entire season. And, it's not just enhanced efficiency for nitrogen in terms of our technologies. I've done studies with the Sulfur Institute showing that if you don't have sulfur, you can lose, up to 30% of your nitrogen just by not having sulfur. So again, how you place the nitrogen in the soil or broadcast has a big role in how much you lose. But again, if you can protect it right from the start, that's really what we're looking at, because that's number one, it has to be cost effective. And with our new technology, we feel that we can bring that price point down, making it cost effective so that it can be mass adopted by the industry.
Thank you very much for your
Thank you.
time today and your presentation. And we hope everyone has a great rest of the Precision Ag Conference. Thanks again, Jeff.
Thank you.